Hi there. So, checking through the Google Classroom comments, I realized a lot of people are curious on how to just find variables from a situation. You know, how to look at a situation or a picture and say, I know what V normal is, or V naught, or I know what my final displacement is. So, since that's a question that keeps coming up, I'm going to do something here called a goal-less problem, meaning it's a problem that doesn't have a specific goal. For instance, here I've got a cannonball that is launched straight upward at a velocity of 50 meters. So I'm going to draw my little cannonball, and it's going up at a velocity of 50 meters per second. Okay. I'm launching it from a cliff that is 30 meters above the point where the ball lands. We'll say the ball lands down here on top of that other cliff. So what's the point of this? Well, I'm going to see where I can find any information whatsoever that's relevant to this problem. So move it down, give myself a little bit more space. The first thing that I need in order to find out more information about this problem is some kind of a reference frame or a coordinate system. So I'm just going to go ahead and say that, well, actually there's a few places I could say are my origin. For instance, I could say that right here is my origin, or I could say that right here is my origin. Now, why would I pick those two places? Well, I would pick the top one because that means that my starting position would be at 0, or I could pick the bottom one to make my final position 0. And either one of those is okay because, you know, I like having a displacement of 0. So I'm going to go ahead and say that this second cliff is located at 0 meters, which means that based on this drawing, the first cliff, the one where we're starting from, must be at a location of positive 30 meters. Okay, so in other words, I have already defined from my picture, from my reference frame, that positive is up and negative is down. So what's next? Well, now I'm going to see if I can figure out any information whatsoever about this problem. Where's a good place to start? Well, what about velocities that are 0? I know the velocity is not 0 here at the bottom because it's moving by the time it lands over there. And I know the velocity up here, however, at the top of its trajectory, the velocity there is definitely 0. So I'm going to put that on my picture. What other information can I determine? Well, I know that during this entire motion, the acceleration due to gravity is negative 10 meters per second squared. How do you know it's negative? Well, remember I defined my coordinate system and I said that negative is aiming downward. Alright, what else can I know? At the very least, I know that the time it takes for the ball to go up is the exact same as the time it takes for it to come down to its initial position. Okay, now that's not the same as the time it takes to go down and land on the cliff below, but it's still something. Maybe I could figure out how long it takes to get here, and then figure out the remaining part. You know, I'm betting that I could figure out the time it takes for the ball to go to its apex, or the highest part of its trajectory. So I'm going to go ahead and do that right now. If I say that right over here is the start and right here is the finish, then that means that I've got a D initial of, it looks like I'm at 30 meters according to my diagram. And my V initial, according to my picture, is 50 meters per second. I know acceleration is negative 10 meters per second squared. I don't know D final, but, oh, I know what V final is, because V final is at the top of the trajectory here. So V final at the top of the trajectory, that's 0. And D final. Oh, I already put that down. I don't know what D final is. Time. What's the time? I don't know, but that's the one I'm going to try to find. Alright, so move myself over here. if I'm trying to find the time it takes for this thing to go up towards the top of its trajectory, then I've got to work with these variables. You know, I think Arthur would work out well, because I have acceleration, and I have my velocities, and I'm just trying to find time. So I'm going to go ahead and rearrange this before I plug anything in. The final minus the initial divided by acceleration. Alright, and now when I plug things in, I will find the final was 0 minus my initial velocity of 50 divided by my acceleration of negative 10, and that gives me time is 5 seconds. Awesome. Alright, so I've already figured out that in this problem, the time it takes to go up to the top is 5 seconds. Awesome. And you know what, I'll put that down here as well. 5 seconds to the top. Well, if I know that it takes 5 seconds to get to the top, it must also take 5 seconds to get down to this point right here. So that's something. I also know that at that point, at this point right here, it's going to have the same velocity, but in the opposite direction. And that's just because of symmetry. I know if we started from 30 meters above 0 with a velocity of 50, then by the time the ball hits that same altitude coming down, it's going to have the same velocity, just the opposite direction. What else can I do? Well, I suppose I could go ahead and find the total time for the whole thing, you know, to go from the top of the cliff here to the top of the other cliff over here. So I'm going to solve that. Where's a good place? I'm going to move this out of the way, and just kind of move that down here. Get that out of the way. All right, cool. So going back up here. Now I'm going to try to find the total time that this thing is in the air. Alright, so once again, I'm going to say, you know, for this one, I'm going to change the final position that I'm looking at. I don't really care what the ball is doing, what the cannonball is doing at the top of its trajectory. I want to know what is it doing at the start and right here when it lands on the other cliff. So, let me set up my variables. My initial velocity, still 50. That's the speed that it was launched at. My final velocity, I have no idea. My initial displacement, according to my picture, is at an altitude of 30 meters. My final displacement, according to my picture, is at an altitude of 0 meters. I know acceleration due to gravity. Even though that's not in my picture, it's just something that you know the thing's moving through air, this is on Earth, it's going to be accelerating with negative 10 meters per second squared. And my time, and I want to find time. Alright, so these are the variables I've got to work with. I know Arthur won't work because I don't have V final, and I know that, well, I suppose I could use Dickey. Yeah, I suppose I could use Dickey, but I really don't feel like doing the quadratic equation right now. So instead, I'm going to use Vicky, and then I'm going to use Vicky to find V final, and then I'm going to use that to help me calculate time using Arthur. So let's get started. V final equals V initial plus 2a delta d. Okay, and I'm trying to find V final first, so 50 squared is my initial velocity, and then I'm going to put in d final minus d initial. D final is 0, d initial is 30. Alright, so I get 2500 minus 20 times negative 30. And what this amounts to, what this amounts to is a positive 600, and so VF squared is 0.3100. Square root both of those, and I get a final velocity of, drum roll please. Oh, the suspense is killing me. Alright, 55.68. I'm rounding it. Meters per second. Okay, cool. So I just found the velocity of this sucker at the moment it lands on the cliff below. I'm going to write that in my table over here. 0.68 meters per second. And I'm going to draw it also on my picture. Why? Just 'cause I feel like it. This is a goalless problem. I don't have to have a reason. Alright, so right here at 0 meters, it's also got a velocity of 55.68 meters per second. Cool. So, and this makes sense, by the way, because, I mean, if you think about it, the velocity up here was 50. The velocity when it came back to the same height was also 50, so the velocity when it reaches a slightly lower elevation on its way downward, well, it should have a little bit more time to speed up, so it's probably going a little bit faster than 50. Not much, but a little bit. And it is. Alright, now I've found my V final. Now I can figure out how much total time it took. So I'm going to take this whole work over here and kind of minimize that, get that out of the way. So much fun which you can do with a touchpad. And I'll do this next one in red. Alright, so now that I found my V final, now I'm going to use this to help me to find time. So here we go. I'm going to use Arthur because it's a lot prettier than Dickie. And right now my pet beta fish is wanting to murder me. Alright, acceleration is -10. V final minus V initial. I gotta write it out because otherwise I know I'm going to make a mistake. 10, let's see, V final is 55.68. The initial is, wait a second. I just caught something. Check it out. Right here, that velocity, at the moment the cannonball hits that point on the ground, it's not positive. I almost made this mistake. I should have made this a negative velocity. Thank goodness I caught myself. Because if you think about it, the ball's going down at the time it lands on this second cliff. So, this is also consistent with the work that I did over here, because if you remember, a square root can provide a positive and a negative answer. And in this case, when I verify, when I check with my picture, the answer should be negative. So, going back over here, I'm going to make sure that my V final is negative, like such. And I'm going to solve for t. I've got negative 105.68 divided by -10, and that gives me a whopping time of 10.568 seconds. Eureka! I have now figured out what the total time of this object in the air is, and that feels really good. So it takes 10.568 seconds for this thing to go from here up and then down all the way to here. Basically what I've done now is I've just found a lot of different information about this picture. And I didn't have a goal, but I'm pretty sure I now know just about everything there is to know about this situation. And that's how you identify variables from a picture.